right. Hi, fourth block statistics. Yes. So I'm getting ready to teach you the last lesson in topic chapter 2. Tomorrow you will review. On Monday, you will take your test. Yay. And then you will do 3.1 on Tuesday, and I'll see you back on Wednesday. Okay. So I am going to share my screen now. It's been a while since I've done this, so I need to share screen. There we go. All right. Getting back the hang of this, post-COVID. Here we go. So 2.6. Yesterday we did normal distributions. Okay, and I showed you how to do second VARs on your calculator and then do normal CDF, and you enter in your lower bound, your upper bound, your mean, your standard deviation, and it spit the answer out for you. The hardest part was determining if negative infinity was your lower bound or upper infinity was your upper bound. Okay. Now, today we are going to find the value that corresponds to a given percentile in a normal distribution. And that'll make more sense as I go. And then we're also going to find the mean or standard deviation of a normal distribution if I'm giving you the percentile, like it's at the 95th percentile. Okay. So we're still talking about those students from Gary, Indiana, the 7th graders that took the reading test, and where, we're talking about what reading level they're on. They had the mean, the average of 6.84 grade level, and the standard deviation sigma of 1.55. So if we look here, we know they're normally distributed because someone told us. So if we draw here, okay, and someone was to say, what would be the score of a student to be at the 90th percentile? So if we drew it here, you can see how we draw it, okay? This area under the curve here, this green area, represents 90%, 0.90 of the area underneath that curve, okay? Here we've done it over to the right, and this is the z-score. And again, this section is going to take you, just like yesterday, the long way around going through z-score, whereas I'm going to take you from point A to B faster by showing you how to do it in the calculator, okay? So we're going to be more focused on the one on the left. So if you look, 90%, okay, yesterday we knew what the number was at the bottom here, where that X is. That's the number we knew, and we did negative infinity to whatever that number is. We don't know that number now, so I can't use normal CDF. But what I do know is the area under the curve is 90. So yesterday you had the lower bound, the upper bound. We did normal CDF, and it gave us the area. Today, we're going to have the area, and I need you to tell me what that lower or upper bound is. In this case here, we don't know what the upper bound is, where that X is. We know it goes to negative infinity, but where does it stop on the right side? Okay. So this is kind of doing the opposite of what we did in 2.5. Now, here's where it gets cool. Remember, I told you, anytime you see a table like this, that's doing it by hand, I can show you how to do it in the calculator. Yes. Okay. So what we're going to do in the calculator, this would be by hand. We're going to go and find what's closest to 0.90. You see that 0.8997. And so you're going to get a z-score of 1.28. Okay. Again, this is all the long way around. Then we got to plug it back into this formula. I want you to see how far they're going, and you don't need to. 1.28, we're going to solve for x. And we end up getting that x is about an 8.824. Okay. Yay, great. But that was a lot of math. Come on, Edwards. There's got to be a quicker way to do it. And there is. We can use the app. Okay. But again, the app is going to give us the z-score. Or we're going to go over here to my favorite, where we are going to use your TI-84. Okay. Now, the big kicker here is, let me see if I can get to where no, I want to go back. I can't find my pencil, so I'm going to here. You're going to do, again, second VARS, but instead of choosing number 2, normal CDF, you're going to go to number 3 and see right here, you want inverse norm. Because we are doing, the first one yesterday was normal CDF. Today, we're doing the inverse of that normal CDF. So the area is, what is that area under the curve? We want 90th percentile, 90%, 0.90. So you're going to enter in 0.90 for area, and it automatically defaults to the mean is 0 and the standard deviation is 1. Leave those the same, okay? So you're just going to hit 0.90, enter, 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 and then it's going to come back and it's going to spit out the answer for you. And that answer you can see right there is 1.28. And again, they went the long way around getting the Z-score. We're going the short way. So again, second VARS, inverse norm, all you have to key in is the area. Okay. You can look at this if you want. This is doing it with the app. Again, I'm telling you, that calculator right in front of you is going to be a whole lot faster. Okay, now, that gave us, sorry, that first one, you're going to kill me. That first one gave you the Z-score of 1.2. We don't need to do that. Okay, so scratch what I just said. Please don't kill me. That gave the Z-score when we leave mean is 0 and standard deviation is 1. But if we want to go the quickest way, second VARS, inverse norm, our area, we're saying we want to know who's at the 90th percentile, so area is 0.9. Our mean was 6.84, and our standard deviation is 1.55. So now I can go right there, boom, inverse norm, and you get that number, 8.8264. So in the 90th percentile is at 8.826. So 90% of the students will fall below that number. Okay. So today, that's what we're doing. We are using second VARS, inverse norm. You put in your area, which your area is either going to be a decimal or it's going to be a percent, and you got to divide by 100 to get it the percent. Input the mean, standard deviation, enter, boom, it spits out your answer. Okay. Now, how do we find these values? You might have to do what I showed you yesterday, and you might have to draw that normal distribution so that you can get it there, okay? You're going to perform the calculations with your calculator. We're going to use inverse norm, okay? So let's do an example. We're using our stop the car again, okay? So we've got one model of car that traveled at 60 miles per hour, typical conditions again, same mean as yesterday, 165 feet. Standard deviation the same, 4 feet. 1% of all such emergency stops take place before what distance? Yesterday, we said what percentage took place at within 40 feet. And I could tell you, there was one was like 99% would crash. Now I'm asking you, 1% of the people are going to be able to stop within how much distance? A lot, a little. What is the distance that only 1% can do? So now I'm doing the inverse of what I did yesterday. Okay. So 1%, think of that as 0.01. 1%, divide that by 100, that's 0.01. So you are going to go into your calculator, okay? And you are going to do, I really, really want to write this for you. Here we go. Okay. So you are going to go into inverse norm. Oh, this is so horrible. Okay. Your area is going to be 10% as a decimal is 0.01. And then you're going to enter in the mean and you're going to enter in the standard deviation. Okay. I'm going to be honest. I don't remember what the mean and what the standard deviation is. Okay. And so then when you go and you put all of that into the calculator, they're going on ahead and they're giving you the z-score. There's our z-score right there, 2.33. We don't need that. And we would get 2.33 if we did area of 0.99, a mean of 0 and 1. Okay? Because what I want you to recognize is if the area up here is 0.01, the other area is 0.99. Okay? So what we end up doing when they do it by hand, they're going to get 174.34. Now, you're probably telling me, Edwards, I did exactly what you told me to do, and I put in an area of 0.01, and I have a completely different answer. Okay? We're not wanting the area of just this little tail here necessarily. This one has to go from left to right. So if I put in 0.01, it's going to give me the mirror image over here. Okay? I need to subtract that number from 1. So if I put in the 0.01, I need to subtract that from 1, or I could do 1 minus 0.01 and do 99. Okay? And so when you do that, you are going to end up getting the answer, putting it in. So either inverse norm, area 0.01, mean 165, standard deviation of 4. Whatever that answer is, you have to subtract it from 1. Or you can do the subtract from 1 on the front end. 1 minus 0.01 gives you an area of 0.99, and then you key them in. Okay? Now, another approach at finding the 90th percentile is to use that z-score. Again, we can use the z-score and do the mean times 2.33 standard deviations. But again, if you've got your calculator, why are you going to do the long way around? Unless you just have lost your calculator. Okay. Now, can we also find the mean or standard deviation of a normal distribution if we have the value of one of our percentiles? Okay. So let's look at this one. Ooh, I need my eraser. Somebody's sitting there going, Edwards, will you take that off the screen? Here we go. So here we got clinical growth charts at cdc.gov, and we've got the percentiles corresponding to different heights for children of each sex and age. 7-year-old girls, the average is 48 inches tall, and 90th percentile is 51 inches. Okay. Now, we are assuming that the height of these 7-year-old girls is approximately normal. So we have 90th percentile value, and we have the mean, but we don't know what the standard deviation is. So how are we going to do this? Oops, I gotta go back. Okay, so the solution is we're going to draw it out. And you can see here's the mean in the middle, 48. We know this number down here, when the value is 51, okay, that is going to be at the 90th percentile. Why? Because they told us. So this is 90 right here. Okay. What we don't know is standard deviation. Okay. So what we need to do is we need to get the z-score. So if we can get the z-score, we can figure out what the standard deviation is. Okay. So what you're going to do here, our area is 90. When we want the z-score, we leave the mean as 0 and the standard deviation is 1. So 0.90, enter, 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 we get a z-score of 1.28. Okay, so I have a z-score of 1.28. What that means is this 51 here, this 51 is 1.28 standard deviations from 48. Okay, so whatever that standard deviation is, when I multiply it by 1.28, I'm going to get 3 units because this is 3 units away. So what I'm going to do now is I'm going to write that equation. Okay. And so what I can do is 1.28 is equal to, I can do it a different way, 51 minus 48. So that's the difference in my two numbers divided by the standard deviation. Okay. And we're going to find out that the standard deviation is going to be equal to 2.34 inches. So again, that z-score, the z-score is equal to the actual value minus the mean over standard deviation. We have the value, which is 51. We have the mean, which is 48. We don't have the z-score, but we can calculate it because of the area and then solve for that standard deviation. Okay, so this is the important formula for you to remember. Z-score is equal to your value, if I say 95th percentile or 10th percentile, minus the mean over the standard deviation. And so when you're given standard deviation and the value of the percentile, you can also kind of do the exact same thing if we don't know what the mean is, or mu. Okay, so if you're given X and you're given standard deviation in Z, we can solve to find mu. All right, so now what if we don't know the mean or the standard deviation? You're probably going, haha, then I can't solve it. Okay. This is where, and I'm going to be honest, I'm even looking at it and going, I have to tell them to do this. They're going to be so mad at me. So we can use both of these two equations and we can solve a system of equations. Remember what you did that in Algebra 1 and Algebra 2? Okay. I could actually set these equal to each other and I could solve. Yeah, I could. Do I want to? Not really, but I could. Yeah. All right. So did we find the value that corresponds to a given percentile in a normal distribution? Yes, we did. And did we find the mean or standard deviation of a normal distribution? Yes, we did. So the key here is what? Stop share. The key here is second vars inverse norm. Okay. Your area is going to be that percentage, whatever it is under the curve. If it's 90th percent, it's a 0.90. If it's 95th, 0.95. Now, if you're given the upper, if you draw it out and it's over here and it's really, really on the right, you can either get the answer, subtract from 1, or you want to take that area. Over here's 0.01. We got to recognize that to this side, it's 0.99. That's what you want your area to be, 0.99. Okay? So we're going to subtract it from 1 first, put it in the calculator. Hope that helps. If you have problems with it, hit me up on Google Classroom, hit me up on Remind, and as long as I'm not busy, I'm going to answer it for you. I'll send something back. See you then.